Today we are going to be looking at bond energy calculations from C5 in Paper 1 Chemistry. Now, the overall energy change is equal to bond breaking minus bond making. That is an equation you have to know going into your exam. You are not given it. If the overall energy change is positive, that means there has been an increase in energy. Therefore, energy has been taken into the reaction and it is an endothermic reaction, energy entered. Now, if there's a negative overall energy change, then this is an exothermic reaction. Energy was lost from the reaction and it decreased. That's an exothermic reaction. It's really important we're looking at sentences like this. In the reaction, the energy released forming new bonds is 93 kilojoules per mole greater than the energy needed to break the existing bonds. What we are saying here is the energy being given out, the energy exiting, is more than the energy we needed. Therefore, this is going to be an exothermic reaction. More energy is exiting, is being released. And therefore, my overall energy change based on this sentence is minus 93 kilojoules per mole. Second example, we are looking at the energy released being less than the energy needed, so the energy inputted. Now that means more energy is needed to be entering the reaction, so it's an endothermic reaction. That means my overall energy change is going to be positive 42 kilojoules per mole. A key part of answering bond energy calculations is identifying the bonds in a picture. In this example, I have a hydrogen-oxygen bond, which is a single bond, and I have two of them. So I have 2 times my oxygen-hydrogen bond. As my second example, I've got in my molecule 1, 2, 3, 4 carbon-hydrogen bonds. I'm going to cross them off as I count them, just to make sure I don't forget anything. And I also have in here 1 carbon double bonded to a carbon. But there's a large 2 here. This 2 means that everything in that molecule is going to be doubled. So if I've got 4 carbon hydrogens in the molecule, overall I'm going to have 8 carbon hydrogen bonds. If I've got 1 carbon-carbon double bond, overall I will have 2 carbon-carbon double bonds. Telling me what bonds do you see in this picture? Write it down, pause the video. The answers will be coming up soon. The answers to this question are that there would be 4 carbon-hydrogen bonds, 1 carbon-carbon bond, 1 carbon-bromine bond, and 1 carbon chloride bond. Bonds are in the picture. Have a go at writing down the bonds you can see. Take care to include the 2. The correct answer is there would be 6 carbon-hydrogen bonds, 2 carbon-oxygen bonds, and 2 oxygen-hydrogen bonds. We're now going to have a go at our first worked example. The equation shows the decomposition of hydrogen peroxide. The table shows the bond energies. Calculate the overall energy change for the reaction. Well, first things first, my overall energy change is equal to the bond breaking take away the bond making. So let's start with the bond breaking. When we're looking at our energy changes, we are going to break every single bond on the left of my reaction arrow, everything I started with. So overall, I have 1, 2 hydrogen-oxygen bonds, but that is multiplied by 2. So I have 4 oxygen-hydrogen bonds. I also have 1 oxygen-oxygen bond, however, that needs to be multiplied by 2, so I have 2 oxygen single bonds. I'm then going to look at my bond making. I am going to build or make every single bond on the right of my reaction arrow. In this case, on the right of my arrow, I have 2 oxygen-hydrogen bonds, but I have 2 times that. So I have 4 oxygen-hydrogen bonds. And I have 1 oxygen double bonded. I'm then going to substitute in the bond energies from this table. So I'm going to do 4 multiplied by my value for OH, which is 463. That is going to be equal to 1,852 kilojoules per mole. I'm now going to do the same thing with my single bond of oxygen. So 2 times 138, which will give me 276 kilojoules per mole. I'm going to add these two values together to give me my total bond breaking, which will give me 1,852 plus 276, which equals 2,128 kilojoules per mole. I'm now going to do the same thing for my bond making. I'm going to substitute in the values from the table. I've got 4 oxygen-hydrogen bonds, so 4 times 463, which is equal to 1,852 kilojoules per mole. And I am going to then substitute in here 1 times 496, which is equal to 496 kilojoules per mole. And that will give me a final bond making of 1,852 plus 496, which is going to equal 2,348 kilojoules per mole. I'm now going to think back to my original equation. My overall energy change is going to be equal to my bond breaking minus my bond making, which is going to give me a final answer of minus 220 kilojoules per mole. In terms of where my marks come from here, this is a 3-mark question. I get 1 mark for my correct bond breaking calculation. I get my second mark for my correct bond making calculation, and my final mark for my correct overall energy change. I have to show the working at every stage. That is very important. Go yourself at this 3-mark question. Pause the video so you have time to answer. This is the mark scheme for the previous question. If you got an overall energy change of minus 818, you are correct. Have a go at this second example question. Pause the video so you have time to answer. Here's the mark scheme for this question. Now my second worked example is now a 5-mark question in your exam, because we're looking for a missing bond energy rather than looking just for the overall energy change. So we're going to start the exact same way as before. I'm going to do my bond breaking, and I'm going to identify the bonds on the left of my reaction arrow, which in this case are 4 carbon hydrogen bonds, 1, 2, 3, 4, 1 carbon double bonded to a carbon, and 1 hydrogen chlorine bond. I'm going to do the same for my bond making, which in this case is 1, 2, 3, 4, 5 carbon hydrogen bonds, 1 carbon-carbon bond, and 1 carbon chlorine bond. I'm then going to now substitute in the bond energies from the table above, which in this case will give me 4 times 413, which equals 1,652. I've got 1 times x, which gives me X. And I've got 1 times 431, which equals 431. On the bond making, I'm going to follow the same process. I have 5 times 413, which is going to be equal to 2065. I have 1 multiplied by my 346, which gives me 346, and 1 multiplied by 339, which gives me 339. I'm now going to add those together. So for my bond breaking overall, I have 1,652 plus X plus 413, which gives me a final answer of 2,083 plus X. I'm going to do the same for my bond making, which is going to be 2,065 plus 346 plus 339, which gives me a final answer of 2,750. I now need to think about the overall energy change. And this comes back to the first skill we practiced in today's lesson, because I have a sentence here saying that in the reaction, the energy released forming new bonds is 56 kilojoules per mole greater than the energy needed. What this is telling me is that the energy released is more, so this is an exothermic reaction. Therefore, my overall energy change is going to be negative 56 kilojoules per mole. So that's going to be equal to negative 56 kilojoules per mole. And I'm now going to refer to my original equation, that overall energy change is equal to bond breaking minus bond making, which will give me a value when I substitute in the values I've determined. My overall energy change is minus 56, so I substitute that in. And that is equal to my bond breaking, and I'm going to put this in a bracket. It is very important that you always put these in a bracket. Take away my bond making. I always rearrange around the bracket first and leave the bracket till last. So the first thing I'm going to do now is I'm going to add 2,750 to both sides in order to isolate my bracket. I now need to have X on its own, so I'm going to rearrange to find X. So minus 56 plus 2,750, take away 2,083, which equals to X. I put that into my calculator. That gives me a value of X being 611 kilojoules per mole. That is the working out I need to be showing for this question. In terms of my marks, you will get 1 mark for your bond breaking, 1 mark for your bond making. You will get 1 mark for the correct substitutions, 1 mark for the correct rearrangement, and 1 mark for your final answer. 6 marks available for this question. Remember, if you do go wrong at any stage, that is okay. You will have error carried forward. So as long as the rest of your method and your working is correct, you will still be able to gain most of the marks. This exam question. Pause the video so you have time to answer. Mark scheme is on the slide. If you got a final answer of 436 kilojoules per mole, you will have done it correctly. At this exam question, make sure to pause the slide so you have time to answer. The mark scheme for the final question. If you got 350 kilojoules per mole, you are correct. If you need any extra help with this, please come and see me and have fun with the rest of your revising.